Okay, everyone. Today we're going to basically talk about that order of operations that we mentioned last time. Remember, they had a problem that was a little premature for us. So, first of all, let's refresh our memory of exponents. Okay, so an exponent can be used to represent repeated multiplication. The base is the number being repeatedly multiplied. So, if we have a number like this is the base, the big number is the base, and the small number is the exponent. Now remember what this means. 2 to the 5th means I'm going to multiply this 2 times itself 5 times. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So all it is just a shorthand version of multiplication. Okay, they have that already written for us. All right, we've already gone over that, but you can look at it if you want in fancy form. Okay, interesting that they used 2 to the 5th and I did also. Funny. Okay, so simplify each expression. So this means -5 times -5. Since there's 2 negatives, I know my answer is going to be positive. Okay. Now this one means -5 times -5 times -5. So look at what that means. Really, if I have a negative raised to an exponent, this tells me there's 2 negatives. I know my answer is going to be positive. This tells me there's going to be 3 negatives. I know my answer is going to be negative. 5 times 5 is 25. Think about quarters. 5 quarters is $1.25, and don't forget it's negative. Okay. Now, I want to make us right quick be aware of the difference between this and this. So be careful about that. The exponent only goes on the one thing it's written on. So right here, this exponent has nothing to do with that negative, right? So this is a negative 5 times 5. But this is -5 times -5. So be careful. That's a really common mistake. This negative has nothing to do with the exponent. The exponent only goes with the single thing it's sitting on. And if it's on parentheses, then it applies to everything inside the parentheses. Okay, so if we're going to simplify this expression, we have 2 cubed, which means if I write it out one time, this is what we have. And then -3 squared looks like this, right? 3 2's being multiplied together and 2 -3's, which means I've got 2 negative signs. Everything's going to be positive. So 2 times 2 is 4 times 2 is 8. 3 times 3 is 9, and I know it's positive because I have a negative. And 9 times 8 is 72. Okay, now I've got 3 negatives, so I know my final answer is going to be negative. So I'm done with worrying about my negatives. My final answer is just going to be negative. And then think about what this is. I have 3 1/2. So remember the way that multiplying fractions work is you can just multiply across the numerators and then multiply across the denominators. So 1 times 1 times 1. And 2 times 2 is 4 times 2 is 8. Hey, that means if I have an exponent on a fraction, I don't have to go to all this trouble to think about, oh, what does multiplying 5 fractions mean? I can just do the numerators and the denominators individually. Okay, so let's think of no negatives to worry about. But because I have a square, this means, oh, 3 times 3 is 9, and 4 times 4 is 16. So 3/4 squared, I don't have to think, oh, what's 3/4 times 3/4? I can do 3 times 3, 4 times 4. Likewise, I can do 2 times 2 times 2, so 8, and 3 times 3 times 3, 27. 3 times 3 is 9, times 3, 27. Now don't forget, when we have fractions, anything we have in common, any factors in common, 9 divided by 9 is 1, 27 divided by 9 is 3, 8 divided by 8 is 1, and 16 divided by 8 is 2. Leaving us with, in the numerator, 1 times 1, and in the denominator, 2 times 3. Awesome, right? Okay, now that we've practiced our exponents a little bit, let's get to our order of operations. So here's what most of us are probably familiar with now. Sorry about that. Now, I hear a lot of people coming out of school with this, PEMDAS, memorized. What it used to be was, it stood for the phrase, please excuse my dear Aunt Sally. You know, our brains are weird little things, and if I just tried to memorize these math procedures, it'd be very difficult. But something like, please excuse my dear Aunt Sally, we can remember. Some meaningless phrase, I don't know about you, but I don't even have an Aunt Sally, but I can remember, please excuse my dear Aunt Sally. The problem with both of these is that, notice where they've got their semicolons here, that my dear and Aunt Sally have to go together. So I see students a lot of times, they do all the parentheses, all the exponents, all the multiplication, all the division, all the addition, all the subtraction. Nope, 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 can't do that. You do the parentheses, the exponents, but then multiplication and division are done in the same step, and you have to do them in the order that they occur. Remember when we were just practicing multiplication and division, we said that? Okay, same for adding and subtracting, although it's not that important, because once we have it broken down to where there's nothing left but adding and subtracting, we know as long as we keep that sign in front of the number, really, we can use the commutative property there. All right, so let's practice it. All right. Please excuse my dear Aunt Sally. Okay, so parentheses first. Everything else is going to stay the same except for the one step I'm working on. And 20 minus 4 is 16. Okay, once I've done parentheses, I do exponents, but there's no exponents. Now I do multiplication and division in the order it comes. This one, the multiplication does come first, but if I had this and then times something, I would have to do that first. Multiplication and division in the order it comes. So 9 plus 16 times 3 is 48 divided by 8. I'm still working on multiplication and division because I still have a multiplication or division. So 9 plus 48 divided by 8 is 6. Okay, and then adding and subtracting. 9 plus 6, 15. We've already seen an example of why we have to do these orders in the correctly, right? in the correct order or we'll get different answers, and that can't happen. Can't have different answers for the same problem. All right. Please excuse my dear Aunt Sally. My dear and Aunt Sally go together. Parentheses first. So 3 plus 2. 6 minus 8. Different signs means minus. So 8 minus 6 is 2. Keep the sign in front of the biggest number. Times 15 divided by 3 is 5. Okay, so I've done parentheses. There's no exponents. Multiplication and division, whatever you come to first. So 3. 2 times negative 2, there's one negative sign, so that means minus 4 times 5, right? If you want to keep those parentheses, that's fine. I still have some multiplication and division, so here we go. 3 minus 20. Now adding and subtracting. Different signs mean minus. 20 minus 3 is 17. Keep the sign in front of the largest one. Okay, please excuse my dear Aunt Sally, or PEMDAS if you prefer, but my dear and Aunt Sally go together. So inside parentheses first, here's a parenthesis, but there's nothing inside there to do. But here, there's actual stuff inside the parentheses, not here. Everything else stays exactly the same. It's really important to make sure everything else stays exactly the same. A positive and a negative means minus. So 6 minus 4 is 2. Keep the sign in front of the bigger number. Okay. I still have parentheses in my problem, but it's just because it's holding negative numbers. There's no operations inside parentheses to do. Hey, this time I have exponents. Here's an exponent. Here's an exponent. So 3 negatives. My answer is going to be negative. And 4 times 4 times 4, right? 4 times 4 is 16. Times 4 is 64. If you have to go over to the side and see what that is, that's fine. Now here's this minus. Okay, this minus. Now, 2 negatives, that's going to be a positive, so 2 times 2 is 4. And then I still have minus 3. All right, I've done all the exponents. Now multiplication and division. Okay, here's a multiplication. Everything else is going to stay the same. I have a negative 4 times a negative 3. So that's going to be a plus, a negative times a negative, 12. There's no multiplication or division left, so adding and subtracting. Signs are different means minus. 64 minus 12 is 52. Keep the sign in front of the bigger number. Okay, this is an interesting one. What I have to remember about this is if I have a giant fraction bar, it's like a grouping symbol. It's as if there are invisible parentheses around the numerator and the denominator. So it's all of this divided by all of this. All right, I got to remember this anytime I have more than one operation. Parentheses first. So here's a parenthesis. Okay, everything else is going to stay the same. Negative 8 plus 5. Signs are different, means minus. 6 minus 4 is 2. Keep the sign in front of the biggest one. All over. Now there's no parentheses in the bottom. All right, I've done all my parentheses. That's just holding a negative number. Exponents. Here's an exponent. Okay. So -8. Everything except the thing I'm working on is going to stay identical. This negative has nothing to do with that square. Only the 4 is being squared, or else it would have been in parentheses, right? So 16 divided by 8. I've done all the exponents. Now, multiplication and division go together. So in the order that it comes, here's a multiplication on the top, and here's a division on the bottom. Because these things are inside parentheses, I can do them independently. So -8, 5 times -2, 1 negative means minus, and on the bottom, 4, 16 divided by 8 is 2, 1 negative, minus 2. I've done all the multiplication and division. Now is only adding and subtracting left. So signs are the same, so add. 10 and 8 is 18. Keep the sign in front of the biggest one. Signs are different, so minus. 4 minus 2 is 2. Keep the sign in front of the biggest. Okay, so now I just have to simplify this fraction. There's 1 negative. 18 divided by 2 is 9. Okay, doesn't matter what the fractions look like. I still follow the same order of operations. Okay, inside the parentheses, there's really nothing to do. There's no exponents, so multiplication and division. Here's a multiplication. So the rest of the problem is going to stay exactly the same. When we are doing multiplication of fractions, if there's anything that we can simplify, let's do that. So this becomes 1 times 2 over 1 times 5. There's no multiplication or division left, so now we have adding or subtracting. When we are adding and subtracting fractions, we need a common denominator, which we could easily find out is 15. So I've got to make equivalent fractions with each denominator 15. How do I make a 315? Multiply by 5. Whatever you do to the bottom, same thing to the top. How do you make a 515? Multiply by 3. Whatever you do to the bottom, same thing to the top. So now this is really -5 fifteenths, and this is 6 fifteenths. Once the denominator is the same, it stays the same. So my denominator is 15, and I add or subtract numerators. They have different signs. That means minus. 6 minus 5 is 1. Keep the sign in front of the larger, which is the 6. So we're good to go. Okay, what do we have now? Don't forget, if there's more than one operation, we have to follow this order. So parentheses first. Here we go. I got to do what's inside the parentheses. Because what's inside the parentheses involves fractions, in order to add or subtract fractions, I need a common denominator. Is it 4? Yes, it is. So I've got to make a 2 into a 4. Okay. Once I figure out what I'm doing to the denominator, do the same thing to the numerator. That makes this 1/4 minus 6/4, all squared. Everything else stays the same. Now, I'm still working inside parentheses. I haven't been able to cross that off yet. I still have parenthesis work to do, so everything else continues to stay the same. But once I have a common denominator, that's the denominator of my answer. Signs are different, means minus. 6 minus 1 is 5. Keep the sign of the larger. Everything else stays the same. Okay, now there's no parentheses left. That's just a negative number being held inside parentheses. There is an exponent though. So I have -2 plus. Now if I square a negative, 2 negatives is a plus, right? And then 5 times 5 and 4 times 4. Now when I look at this, there's no exponents left. There's no multiplication or division left. So I'm just adding or subtracting. Anytime I'm working with fractions, I need both of my, or everything, to look like a fraction. So I'm going to make that constant term of 2 look like a fraction. Now, if I'm adding fractions, I need a common denominator. It is 16. So how do I make this 16? Just multiply by 16. Once I figure out what I have to do to the denominator, do the same thing to the numerator. Okay, that makes this -32 over 16 plus 25 over 16. Once the denominators are the same, it stays the same in my answer, and I just add or subtract the numerators. They have different signs. Different signs means minus. 32 minus 25 is 7. Keep the sign in front of the biggest number. Don't forget to check to see if your fraction will simplify, but this one will not. Okay. A complex fraction is when we have a fraction where the numerator and or the denominator are also fractions. It goes without saying, like simplifying a fraction goes without saying, you don't have to be told, find the answer and then simplify, right? It goes without saying. Same thing with a complex fraction. We can't have fractions inside of fractions. We need an integer, a single whole number for the numerator and for the denominator. But remember what a fraction bar is. It's just a different way to write divide. So I could rewrite this problem as -4/5, right? -4/5 divided by -3/10. That's all a complex fraction is. Now, they're both negative, so that means my answer is going to be positive, so I'm done worrying with those. If I'm dividing fractions, I copy, dot, flip. Anything that I can simplify, I will. 5 divided by 5 is 1. 10 divided by 5 is 2. And then you multiply straight across. 4 times 2 is 8. 1 times 3 is 3. So while these complex fractions look really, really nasty, they're really, really not. Okay, I think there's one more. Complex fraction. Okay, so all that means is this is 2/3 squared divided by 6. Okay, remember if I'm working with fractions, I want everything to look like fractions, and I could have written this in my first step, but just for emphasis, I'm showing the progression. Okay, now parentheses first, nothing to do in my parentheses, so then I move to exponents. I do have an exponent, so this is 2 squared, 3 squared, divided by 6/1. Then multiplication and division, and I have a division. To divide fractions, it is copy, dot, flip. Multiplying fractions, see if anything will simplify. 4 divided by 2 is 2. 6 divided by 2 is 3. And then multiply straight across. 2 times 1, 9 times 3. Awesome, awesome, awesome. I think that was the last one. So if you have questions, let me know. Good luck.